Welcome to MOVITRAC LTP-B Basic and Intermediate Training. This is Session 5. In our last session, we learned a lot of different things. It was actually kind of a long session, but we wrapped up by learning how to use the LT shell program so we could engineer our VFD with the PC. Well, there was a lot more to cover than we covered in that session, so we're going to just pick up in this session by talking about more engineering topics using a PC. We're going to get you up to speed in some additional tools that are built into LT Shell. These will let you really exercise your VFD and do some very powerful things. So let's get going. Just a quick review from the last session. As you recall, LT Shell has 3 different modes that you select with the Mode Select buttons. The one we covered in the last session was parameter editing. This is what you'll be using most of the time as you set up your VFD. However, there are 2 additional modes. There's the drive monitor, which allows you to monitor the drive when it's operating and also run it in manual mode. And then there's the scope tool, which is used for diagnostics and troubleshooting. We're not going to cover the scope in this session. It's actually a more advanced topic. We'll be covering it a little later in a different session. So we're going to focus primarily on the drive monitor. So let's talk about the drive monitor and how you can use it to do different things. Well, when you click the appropriate button to bring up the drive monitor, you'll get into the drive monitor screen, which looks something like this. It shows running drive information, and it also provides manual control. Let's just take a quick look at the different features available in the drive monitor. First of all, we have a group of parameters, which are the monitored parameters. When you activate monitoring, these will change to reflect their current status. There's also a selectable parameter that you can pick to monitor, and actually you can add additional selectable parameters if you wish. I'll show you this later. In order to monitor the parameters live, you need to click the Enable Real-Time Monitor button. This is sort of like the real-time editing button in the parameter edit mode. It starts an active communication session with the VFD and starts transferring information to the monitored parameters so you can see them changing live. If you forget to click this button, nothing will be changing. So if that happens, just remember you forgot to click the button. I can't say it enough. You're going to have to always remember to click this button because it doesn't happen by default. In real-time monitoring mode, the monitor will update as the drive will run. You'll know you're in real-time monitoring mode because the little green light in the lower left corner will blink, and of course the parameters will change as well. These are the running parameters. They'll tell you things like the motor's speed, they'll tell you how much current it's drawing, how much power it's using, and its heatsink temperature. All very useful things to know. This parameter here will tell you what the VFD's control mode is. In this case, it's in bipolar keypad control mode, but it could show unipolar keypad control, terminal control, or field bus mode. This is just telling you what's commanding the VFD what to do. The next parameter monitors the digital inputs. You'll be able to see their on or off status by the 1s and 0s there. Very handy as well. The next column is the DC link voltage. It's actually called DC bus voltage in LT Shell, but that's the same thing. It's that high voltage DC that's being stored in the filtering capacitors. This is extremely useful because it gives you an idea of the health of the VFD. If the DC link voltage changes and becomes either very high or very low, then something is wrong. And then we have our selectable parameter that you can pick. In this case, I've assigned it to monitor the 2 relays that are built into the VFD, but you can set it to lots of different things. And then off to the right, there's the option of another selectable parameter. You may wish to have several. And then finally, we have 2 very important controls. We have a start and stop button. These are our manual controls. These allow us to just test the drive very quickly. So let's talk about manual mode because that's something you'll probably use just to confirm that everything's working. It lets you directly control the VFD. It doesn't matter what mode it's configured. You'll be able to override that and just pop into manual mode by going into the monitoring tool, selecting real-time monitoring, and activating these 2 controls. These are obviously start and stop buttons. They let you command the drive, and then you can specify the speed at which you wish it to run by putting in the speed right there in RPM. Pretty simple and straightforward. Once you've activated the drive, the running parameters will update to show you what's going on, so that is very handy, and that will give you an idea if everything is healthy and doing what you expect. I think it's time for a demonstration. Let me show you how monitoring mode works. I'm going to fire it up on my demo unit, and I'm going to run my drive and point out a few things. So here we go. All right, well, let's give the monitor tool a try so we can see how we can operate the drive in manual mode and how we can monitor its behavior when it's running. As you can see, I've fired up LT shell. I haven't yet connected. I'm going to just leave my network scan limit set to 1 since I have just one VFD connected up and it's using the default address. Then I'll go ahead and click the Scan Drive Network button to detect my VFD. And you can see it's found it and it's loading its parameters into the LT shell project. There we go. All right, so now that we're connected, I'm going to switch to the monitor tool by clicking the monitor button. You can see we've switched to the monitor tool screen, but nothing's updating, and that is because we're not yet in real-time monitoring mode. Remember, you always have to click that real-time button to see things happening live. I'm going to click that, and you'll see the green lights start to blink, and now all the parameters have become live. We look up here, we can see that our motor is stopped, it's not turning, it's not drawing any current, it's not using power, the heatsink temperature isn't changing. We're in keypad mode. You can see our digital inputs here. The DC link voltage is changing. You can see it jumping around a little bit. Now at the very end here, we have the option of adding a user-selected parameter that we wish to monitor. Actually, you can keep adding things off the end as you put ones on. Let's just add one here, and I'm going to pick motor voltage, so we'll see the motor voltage change as the motor runs. Right now it's 0, of course. Let's run the drive. We'll key in a speed. Let's pick 750 RPM, and we'll go ahead and press the start button. And you can see we switched to running, and we accelerated up there to 750 right away. Notice our motor current has now changed, motor power, the heatsink temperature is warming up, and our DC link voltage is moving around a little bit, and our motor voltage has changed. Let's double our speed. Let's go to 1500 RPM. It should jump up to around 300 volts, and it has. If we want to reverse the direction that our motor's turning, we just have to click the start button again. That's just like you would do on the front of the VFD. So there we go. We decelerate and reaccelerate in the other direction, minus 1500 RPM. We'll reverse again, go back. So there we go. Let's stop our drive and disable real-time monitoring. So that's the monitor. Handy tool, very useful for testing and any other situation where you want to monitor the operating VFD. All right, time for a new LT shell topic. We're going to go back to parameter edit mode because inside that is a feature that is extremely useful. That is the ability to back up your parameter set to a disk file and then restore it later, either onto the same VFD or onto a different one. Backups and restores can be extremely helpful and definitely can save you time. I recommend that whenever possible, you should always back up a VFD once you've gotten it set up and running and then put that file in a safe place. You never know when that's going to save you some time down the road. It's just a smart thing to do. So let's talk about how to do backups and restores. Well, of course, you need to be in parameter edit mode. You need to be online with the VFD, and you need to have scanned into it so that its parameters are currently active on the screen. Now, once you've done this, you create the backup just by saving the current LT shell project. Now, what if you're not absolutely positive that the parameters in your LT shell project are current with what's in the VFD? Well, if you're insecure about this, it's not a problem. You can force LT shell to read the VFD and load the parameters into the project. You do it with this button right here, which has the green arrow pointing out of the VFD. So give that a click. Wait for the 10 seconds or so that it takes to read the parameters, and then you can be absolutely sure what's in the project reflects what's in the VFD. Now, as soon as you've done that, the next thing to do is click the little old-fashioned floppy disk icon, and that's going to save your LT shell project to a file. And that file is a complete backup of the entire parameter set. So put that wherever you wish on your local disk storage, and you're good to go. That's all that it takes to make a backup. This has nothing to do with backups, but I'm going to point it out right here. This is a good time to talk about it. What if you want to factory reset your VFD from within LT Shell? Can you do that? And the answer is absolutely. You don't have to hold down that keypad button combination. You can simply click this button right here, and that will wipe your VFD and set it back to the factory defaults. So that's just handy to know. You can reset your VFD from right here. All right, let's return to backups and restores. How do you restore a backup file onto a VFD? Well, it's pretty simple, although there are a number of additional steps that you have to do. And the first is you have to switch to what's called offline mode. So if you've scanned into your VFD, what you need to do is put it in offline mode before you can transfer the backup file onto it. You do that by clicking this button right here that says offline mode. You'll know you're in offline mode because the project will go away and be replaced with that generic template project. The next step, once you've switched to offline mode, is to click the Open Folder icon right next to the floppy disk icon. Navigate to your backup file wherever it is on your local disk storage. It'll load into the project, and you'll probably see this message here. It'll say a drive already exists with this address. Do you want to overwrite it? And that is perfectly fine because it's overwriting the template project in LT Shell. And now it's time to transfer the parameters from the project into the VFD. So you click this button, the one with the yellow arrow pointing into the VFD. This will transfer the project. This is similar to what you do in batch edit mode. In fact, it's identical. You're transferring the entire project and all the parameters in it to the VFD. Now, something different will happen here that does not happen in batch edit mode. You're going to see this dialog, which will pop up. It's asking for the drive's address. You need to open the pull-down menu right here and pick the drive's address, so you'll need to know what that is. In most cases, it's going to be 1 if you're just set to the default address. But if you know it's different, of course, change it to whatever's appropriate. Then click OK. What it will do is transfer that parameter set into the VFD, which will take about 10 to 15 seconds. And that is it. Now, once you've done that, you're still in offline mode, so what you'll need to do optionally, but probably you'll want to do this, is go back into online mode. To do that, you'll need to scan back into the network, so just click Scan Drive Network. It will scan, see what VFDs it can discover, and go back into online mode. And that is it. You will have restored your backup into your VFD. All right, I think it's time for a hands-on to get a little practice with this. We're also going to explore a few things that we talked about 2 sessions ago when we talked about different ways to stop your VFD. I want to give you a chance to play with that. So here's what I'd like you to do, and you may need to go back 2 sessions and review if you're a little fuzzy on a few of these things. I'd like you, first of all, to get connected to your VFD with LT Shell, so you'll need to get your cables hooked up, load LT Shell into your PC, and then, of course, fire it up. Scan into your network and see if you can access your VFD. Once you've done that, you'll go into parameter edit mode, and I'd like you to do these things. I'd like you to change the regular stop mode to ramp to stop. I'd like you to change the power failure mode to fast ramp to stop. Set the normal deceleration ramp time to 10 seconds. Set the fast ramp time to 1 second. And then change into drive monitor mode to activate the real-time monitoring and run the drive in manual mode at 1500 RPM. I picked 1500 RPM because on a 4-pole motor, that means those ramp times are going to be the actual time the ramps take. In other words, normal deceleration will be 10 seconds, coming down from 1500 RPM to 0, and the fast ramp will be 1 second. Now, of course, if you don't have a 4-pole motor, things will be different, but I'm assuming you do, and that's what I have on my demo unit. Now, once you've run the drive and just confirmed that it works, I'd like you to take out your smartphone, fire up the stopwatch app, and I'd like you to test the normal stop deceleration, confirm that it's a full 10 seconds, and then test power failure mode. And I'll just give you a little hint how to test that. Just flip the off switch and see what the VFD does. See if you get that fast deceleration or not. Once you've done that, of course, turn your VFD back on, wait for it to come up, reconnect, and then back up your parameters. Back them up to a file, save them somewhere on your local storage, then factory reset the VFD using LT Shell, not the keypad, and then restore your backup into the VFD and confirm that everything is back where you expect it to be. All right, it's a lot of things to do, but they're all easy things to do, so go ahead, pause the video, and do the hands-on. All right, well, I hope that went well. I'm going to demonstrate how to do all those things. So if you didn't have a demo unit, you can watch it here. And if you got stuck with something, then this should unstick you. So here we go. As you can see, I've fired up LT shell. I need to scan in and get connected to my VFD. So again, I'm going to just leave the network scan limit set to 1 because that's my VFD's address. And I'm going to click the scan network drive to get connected. So there we go. We found the VFD. Scanning in, loading the parameters into the project. This, of course, will be from our last activity. Now we're going to make some changes. And we always have to remember if we're going to change parameters in real time, then we need to click the real-time edit mode button to switch to live editing. Otherwise, when we change parameters, they will not change in the VFD until we click the upload button. So I prefer editing in real-time mode. Now the first thing we have to do is set the regular stop, which is parameter 1-04, to 10 seconds. It's going to give us a nice gradual deceleration for normal stops. Our stop mode must be set to ramp to stop, and it's already set to that in parameter 1-05. Nothing we have to change there. Now we need to set the rapid stop ramp. That's parameter 2-25. We need to set this to 1 second, so we will change that. And then we need to set the power failure handling mode to fast ramp to stop. By default, it's in ride it out mode, so we change parameter 2-38 from ride it through to fast ramp to stop. And that is all we have to do. We've now fulfilled everything we needed to. According to the instructions, we now switch to the monitor mode. We're going to run our drive and do some timing. We need to enable the real-time monitor. And we're going to go ahead and set our speed to 1500 RPM so that those ramp times will correlate to their actual times. I'll put 1500 RPM in here and I'll press the start button. Of course, I have enabled my drive, that goes without saying. And we've accelerated up to 1500 RPM. That happened very quickly because we had a 2-second ramp. Now we're going to time the deceleration. We're going to come down from 1500 RPM to 0. That should take 10 seconds, so let's go ahead and time that. And it definitely is taking some time to decelerate, so I think our ramp is working, but we'll let the stopwatch confirm it. Okay, I think that definitely confirmed it. We had a nice 10-second deceleration. Now we're going to test power failure mode. So to do this, we need to re-accelerate our drive, so we'll start it up again. And then what I'm going to do is flip the off switch on my demo unit. That will cause the mains to fail. The VFD should decelerate it quickly using the 1-second rapid stop ramp. And I'm going to actually then turn the power right back on again before the VFD loses complete power. Here we go. So there we go. That obviously took 1 second. And I'll just mention as an aside, my VFD never actually completely powered down. The filtering capacitors inside were able to keep it up, so it was able to complete that ramp, and when I turned the power back on, it just resumed normal operation. Of course, it didn't restart the motor because we weren't in ride it through mode. It did ramp it to a stop, bring it to an orderly halt, and now it's just waiting for me to tell it what to do. So if I want to run it again, I'll just click the start button, and that will re-accelerate it back up to speed. Let's do that. So there we go, up to speed again. And let's go ahead and stop our VFD. I'm going to click the stop button, and you see now we're using that 10-second down ramp again. So it looks like everything is working correctly. So now we're going to do a backup of our VFD. So we disable the real-time monitor mode, go back to parameter edit mode, and we're going to save our existing project. If I was really nervous that my project reflected my VFD, I could click the load parameters button. That's the VFD with the green arrow pointing out of it. But I know since I've just been editing my project that my project does accurately reflect what's in the VFD. So I'm just going to click the floppy drive icon to save the file. I'll accept the default file name and I'm going to save it on my desktop. That's a convenient place to put it. So we'll save it there. And that's all that it takes to create a backup. Making a backup is pretty simple. Now what we're going to do is factory default our VFD. So we're going to reset it back to a clean slate. And in order to do this, I always recommend, first of all, disabling the VFD by turning digital input 1 off. And I'm going to also put it in controller inhibit mode. You don't have to do that, but I like to do it because it's kind of an extra safety layer. So I'll turn the 2 switches associated with my safe torque off inputs to the off position. My VFD now says inhibit on it, and I'm going to factory default it. Just a reminder, whenever you factory default the VFD and then you load the parameters in, the very first thing it's going to do when you try to run it the first time, it's going to try to auto-tune itself. So my VFD is going to auto-tune at the very end when I try to run it. So don't forget that. Always remember auto-tuning will be in the picture if you factory default your VFD. All right, so my VFD is ready to be reset. I'm going to click the factory default button. And it gives me a chance to bail out of this, which is nice if I don't want to do it, but in my case, I definitely do. So I click go ahead. It clicks and it clears itself. So now we're ready to restore it using our backup file. To do this, though, I have to go into offline mode. So I click the offline button. When I do this, it reverts back to that template project. Now I'm going to open my backup file by clicking the open folder icon. And there's my backup file. By the way, I just want to call your attention to the file name. Notice that our backups have these really long file names, but the file name is actually informational. It has the basic qualities of the VFD embedded right there in the file name. It says it's a MOVITRAC LTP-B. It says that it's a 460 volt model. It's a 1 horsepower model, and it has firmware version 1.26. So those long file names may look a little cumbersome, but actually they're very useful. Of course, you can always change to a different file name if you wish, but the defaults actually I think are pretty good. All right, so we're going to load that file, and it says a drive already exists with this address. Do you want to overwrite it? All it's going to do is overwrite that template project, which is perfectly fine. So I will say yes, and it's now loaded into LT shell. What I have to do now is simply upload it into the VFD. So I'm going to click the button with a yellow arrow pointing into the VFD. It's going to ask me for the address of the VFD I want to use. My VFD is on the default address since I just reset it, which is address 1. So I select 1 and I click OK. And now it's transferring those parameters into the drive. And there we go. It's now been restored. I have to scan back into the VFD to go back to online mode, so I will do that. That will take a few seconds. So my VFD has now been factory defaulted. I have restored my backup file into it, and it's ready to go. But of course, it is going to have to auto-tune because factory defaulting makes it want to auto-tune. So what I will do is I will remove controller inhibit by turning my 2 safe torque off switches on. I will enable it by turning the digital input 1 switch on, and I'll press the start button, and as soon as I do that, it's going to auto-tune itself. I'm not going to show that because you've seen me do that before, but once it completes auto-tuning, it will be ready to run, and then I can do whatever I like. So I think we've completed all the required activities in our exercise. Hope that lined up with what you did. If not, hopefully it made it make sense. And that is the end of session 5. It wasn't very long, but that's good because session 4 was pretty long. In our next session, we're going to learn something very important and very powerful. It's in fact going to take 2 sessions to cover it. We're going to talk about terminal control mode, sometimes referred to as binary mode because you control the VFD with external switches. You'll discover that the MOVITRAC LTP-B is extremely powerful when run in terminal control mode. There are many ways you can operate it. We'll cover just a number of them, but I think it'll give you a taste for what you can really do. So, see you next time.